Question number 1. Graph the following function, then write the characteristics for the graph. All right. Well, we need a graph of this particular function. I'm noticing that there is an a value, there's a c value, there's no b value. So since we commonly use the equation x is equal to negative b over 2a to find the x value of the vertex, and there is no b value, that means its realistic value is 0. 0 but divided by anything is 0. So that tells me right off the bat that the x value of the vertex is at 0. The axis of symmetry is x equals 0. The domain is negative infinity to infinity because it is a quadratic. All right, let's come back up to our graph. We know that our x value is 0, which means it's on the y-axis. If I plug a 0 into the equation, f of 0 is equal to negative 1/2 times 0 squared minus 3. Negative 1, sorry, let's start with 0 squared is 0. 0 times negative 1/2 is 0. 0 minus 3 is negative 3. So an f of 0 is equal to negative 3. So we got 0 down 3. Now, hopefully you're still familiar with the scale rule. The scale rule tells us that we can take this value and we can multiply it by our first scale movement to know how far we should move. If you're not familiar with the scale rule, that's fine. There are other ways of identifying ordered pairs. So, let's review some of those. We can certainly create an XY t-chart. Now we can see that there is a negative value in front of our A, so the graph is going to be flipped upside down in a cave format. And we can tell that we have a vertex at 0, negative 3. So the next ordered pair we would like to know is usually 1 away from the vertex. So we would want to know where 1 is, we would want to know where negative 1 is. If I want to know where 1 is, I'm going to plug 1 into my equation. So f of 1 is equal to negative 1/2 times 1 squared minus 3. Well, 1 squared is 1 times negative 1/2, that's negative 1/2. Minus 3, so an f of 1 is equal to negative 3 as a fraction over 2 would be negative 6 over 2, which would give us negative 7 over 2, or negative 3.5. All right, so we come forward 1, down 3.5. We come backwards 1, down 3.5. We've found our next set of ordered pairs. Now we can certainly find out what happens when x is 2. Same process. We're now going to plug in f of 2 equals negative 1/2 times 2 squared minus 3. 2 squared is 4 times times negative 1/2 is negative 2 minus 3. So an f of 2 is equal to negative 5. 2, negative 5. Negative 2, negative 5. And now we've got a good sense of the movement on our graph, so we can connect the dots. And articulate the range. Now the range is the set of all of the possible y values. So for this particular graph, the range starts from somewhere way down here and moves up until it gets to negative 3. That's the highest point on the graph. It doesn't go any farther beyond that. So it starts at negative infinity and increases until it gets to negative 3. All right, the increase. By increase, we're talking about where does the graph go up from left to right. We report the increase in terms of x values. So moving from left to right, when does it stop increasing at what x value? Well, it stops increasing at the x value of the vertex, which we know to be 0. So the increase would be negative infinity all the way up to 0. When does it decrease? Well, at the point that it stops increasing, it begins to decrease. So from 0 forever on to infinity. All right, end behavior. End behavior starts at the point of vertex or at the y-axis and says, if I move to the left, well, moving to the left is as x approaches negative infinity. What is happening to my y values? Well, as we move further left, my y values are moving further down. They are approaching negative infinity. Oops, y approaches negative infinity. All right, as my x approaches infinity, y is approaching, well, now as my x's go further and further and further and further to the right, my y's are going to continue to go down. That will also be negative infinity. The extrema, the highest or lowest point in our parabola, the highest point in the parabola for this quadratic is the vertex, and so that's going to be a we'll go ahead and list it as the vertex point, 0, negative 3. Number 2. Well, this time we were given vertex form. The nice thing about vertex form is we already know that the vertex is the opposite of the value inside. Keep the same as the value outside. So the opposite of inside would be 1. The same as the outside would be up 3. We've got a vertex point. Now this time we're going to use the scale rule. So let's notice a couple of things. We have a negative, which again means we're going to have a cave, just like the previous problem. It's got a scale of 2. So on a traditional graph with a scale of 1, we would move down 1 over 1 from the vertex point. Since this has a scale of 2, we're going to move down 2 over 1. It creates a vertical stretch. Now, on a traditional graph from here, we would move down 3. But since we have a scale of 2, we're going to move down, you got it, 6. 1, 2, 3, 4, 5, 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And so we have very quickly graphed a vertical stretch with a scale factor of 2 and negative a value, which means it flips it over the x-axis, with a vertex of 1, 3. That didn't take long at all, did it? Now, again, you can certainly do like you did on the previous problem, create a t-chart, plug in one x value to the left of the vertex, one x value to the right of the vertex, and find out your y values, and then do it again. Go one more to the left of that second point, go one more to the right of that second point, and you'll end up with 5 points that you can graph. That takes a lot more time than using the scale rule, so I encourage you to try your best to be familiar with the scale rule so that you can save time on the test for more challenging questions. But that is the process. The vertex. Now, we already identified the vertex as 1, 3. The axis of symmetry is always the x value of the vertex, so x equals 1. The domain is always negative infinity to infinity on a quadratic. The range, this is a cave, so it's going to be coming from negative infinity all the way up. As it goes up, it approaches 3. the increase. Again, we're increasing from left to right. So we increase from negative infinity all the way to the x value of 1. Once it makes it to the x value of 1, the line of symmetry, then the graph begins to decrease. So from 1 to infinity, it is decreasing. End behavior. As x approaches negative infinity, y approaches negative infinity. So again, as my x's go further to the left, my y's are going further down. As my x's go further to the right, my y's are going further down. So that will also be as x approaches infinity, y approaches negative infinity. The extrema, again, we're going to continue to list as the value of the vertex. 1, 3, you'll learn more about that when you start getting into graphs with more than one curve. Number 3, f of x is equal to x plus 2 squared minus 5. So again, we're in our vertex form of the equation. So we want the opposite of the inside. Keep the same as the outside. So negative 2, negative 1, 2, 3, 4, 5. Now this time, notice there is no value in front of the binomial squared, which means the a value is known to be a positive 1. That's nice because we can use our scale rule without needing to do any scale factor adjustments. All right, since it's positive, that means we're making a bowl shape. So from the vertex, I will go up 1 over 1, up 1 over 1. So we've gone up 1 and to the left 1, up 1 to the right 1. From our new ordered pair, we will go up 1, 2, 3 more over 1. The same on the opposite side. And we have now created 5 points to give ourselves a guide for our quadratic. Now, as we identify the vertex, we already have done so. Negative 2, negative 5. The axis of symmetry, again, is always the x value of the vertex. So x is equal to negative 2. The domain for a quadratic is always negative infinity to infinity. The range for a quadratic, well, this quadratic, where is its lowest value? Its lowest value is actually at negative 5. So notice a little bit different from our previous question where we always started at negative infinity. That's because this particular problem doesn't go any lower than negative 5. But it does, however, continue to go up forever. So from negative 5 to infinity. The increase. Now this is also a little bit different. From our axis of symmetry, it's increasing from the right of the vertex. So our vertex has an x value of negative 2. It is increasing from negative 2 forever to the right, to infinity. Where is it decreasing? It's decreasing all the way up until it gets to negative 2. Well, where did it start decreasing? From negative infinity. End behavior. As x approaches negative infinity, we always start negative infinity to, then we go to infinity. So these statements are pretty consistent no matter whether you're dealing with linear equations, quadratic equations, exponential equations. As x approaches negative infinity, y approaches. So as my x's go further left, which direction do my y's go? They go up. So y is approaching infinity. As x approaches infinity, in other words, as my x's go further to the right, my y's go further up, so they are also approaching infinity. All right, the extrema, again, we're going to list as the vertex point, highest point in this parabola. So that will be negative 2, negative 5, sorry, not the vertex point, the highest or lowest point in the curve in this particular parabola, so negative 2, negative 5.